And now for the next pilot written test question, the ones that ominously begin with these words. They menacingly demand more focus to decipher hidden messages in their ancient symbols and pictographs. In this mission, we will fight the FAA's challenge they have prepared with figure number 40, translated to the airplane takeoff distance graph. At first glance, it may look more confusing and intimidating than it really is, but it's not that complicated. Wait, so why am I being so dramatic here? I recently found how to add those video chapter or section labels on this timeline so you can scan through what parts of this video may appeal to you if you need. Here we will cover 2 practice questions. The first one will be done with explanations if it's your first time working with this chart, and if you prefer a much more brief demonstration, feel free to skip ahead to the second practice question. Take from this video what would be most helpful. Well, we're off to getting started then. Take a look at the contents of this chart and you'll notice that it involves conditions like air temperature, weight, wind, and obstacle height, which are all considerable factors to be aware of while planning for a takeoff. When finding takeoff distance, we are only focusing on this yellow highlighted area, as we're about to see with the demonstrated questions. Up at the top, we have 3 blue text boxes, and the information in here relate to the example case description that's drawn onto this chart. They also correspond to these red arrows you see across the chart itself. This example may come in helpful to some people on certain occasions, but don't let it distract you when you're looking to solve a question that does not relate to this area. Moving on to the sections we will be using, starting in the lower left corner right below the graphed area, we have a section dedicated to outside air temperature, often abbreviated to OAT. There are 2 separate temperature scales, one for Celsius and the other for Fahrenheit, which is placed right below the Celsius scale. Moving above the temperature section, now highlighted in green, this is an area dedicated to the pressure altitude conditions. Next to that in the purple area, we enter the section dedicated to aircraft weight conditions, and next over in blue is the wind component conditions. And finally to the right of that in orange is the section for obstacle height. The listed numbers on the far right edge of the entire chart itself, highlighted in green, will be the distance in feet that will be needed for the combined given takeoff conditions. The higher we go on the edge of this chart, the greater the takeoff distance reading will be. When using this chart, the steps will have us proceeding through in a general path going up, then from left to right, but it will end up looking more crooked, similar to this in actuality. To explain why, let's try 2 practice questions to demonstrate the additional details of this chart. I will do my best to visibly demonstrate the steps in the process by magnifying sections on the chart, but I think it may be easier to follow along if everyone had their own copy to work with. This particular chart will be included within a document titled the Airman Knowledge Testing Supplement, as you can see its cover featured here. A free PDF is available on the FAA website at faa.gov. I will include the link for this in the video description below. Now for our first question, determine the approximate ground roll distance required for takeoff, and with it we are provided the following information: an outside air temperature of 95 degrees Fahrenheit, a pressure altitude of 2,000 feet, takeoff weight 2,500 pounds, and a headwind component of 20 knots. At this point you may have felt these descriptions sounded familiar, and yes, they will be included in the chart. So to solve for the distance required for takeoff, we will simply be plugging in this information right into the chart. And for the written test formats, we will be offered the 3 possible answer options, with only one of them being correct. First item on the list is our given temperature of 95 degrees Fahrenheit. We will begin our first step down here on the lower left corner of the chart, and remember that there are 2 different scales present in this area. Take care in selecting the appropriate scale for any given question. We will line up at 95 degrees on the Fahrenheit scale, and from that point, we will track straight up into the pressure altitude section of the chart above. It often helps to draw a thin line up towards the first set of black guidelines up here, and we will find where the line will come to a stop by the next given information from our question, which is a pressure altitude of 2,000 feet. We will stop right at this point on our line. See here that these heavy lines are labeled by increasing pressure altitudes. We will choose the one labeled as 2000 as it matches our given conditions in the question. By the way, the line below that one labeled SL represents sea level or 0 feet. When we come into contact with a 2000 foot pressure altitude line, we will track straight across to the right up to the reference line for the next section on the chart, the aircraft weight area. At this next stage, we will look below to refer to the weight scale and find the number that applies to the given question. Our given weight is 2,500 pounds, and from that point on the scale, we can draw a guideline straight up going right through the heavier lines above. We can use this line to guide us to our next point, starting with where we left off in the pressure altitude section. Going back to the last point we made here, we will continue tracking forward in a path that will be consistently parallel between the surrounding black guidelines, and come to a stop at the point where we reach our blue dashed guideline we made going up from the 2,500 pounds mark. Here is what I mean by moving parallel to these black guidelines. I drew a pinkish magenta line, and as you can see, this line mimics the trend between the two neighboring guidelines. When drawing our lines for any given question scenario, they won't necessarily always be positioned exactly in the middle between the guidelines, like in this magenta line example. In some cases, we might have our line closer to one guideline than the other. This is because it would depend on what number we arrived at with the previous position on the pressure altitude section. The important thing is that our lines mimic the downward or upward trend of the lines it's nearest to. So let's do exactly that with our current question applied, and in this case I happen to be almost perfectly overlapping this black guideline here, pretty much tracing right over it, and we will come to a stop at the point where we meet the guideline we drew for ourselves for the weight of 2,500 pounds. And from that point we will proceed straight across, this time no longer parallel with the black lines beyond the point of 2,500 pounds. We will come to a stop when we reach the reference line before the next section for the wind component. This pattern of tracking parallel with the guidelines up to a certain point, then going straight across to the next reference line applies to the remaining sections of the chart, including weight, wind, and obstacle height. We will be doing the same routine we just did in the next section. Now in the wind section, we are given two sets of guidelines to choose from. The solid downward trending lines represent the headwinds. The upward trending dashed lines represent the tailwinds. Knowing which set of lines to follow is simple by referring to the given conditions in our question, which states here that we have a headwind component of 20 knots. We will be traveling parallel along the downward trending headwind lines until we reach the 20 knots mark here. And then from that point, we will go straight across to the next reference line. If we encounter a case where there is no headwind or tailwind, essentially calm wind conditions, we would not have to travel parallel to any lines and simply go straight across the entire section from beginning to end. Now we have arrived at the obstacle section. Looking back at the question, we will see that it is only asking for a ground roll distance, not a takeoff distance that includes clearing any possible obstacles. So this part of the section does not apply to what the question is asking for. When something does not apply, such as in this case, no obstacle involved, we would simply travel straight across from our last point all the way to the edge of the chart. Now we made it to the finish line and we will read our takeoff distance at this edge. Each of the individual fine blue lines is a 100-foot increment from the 0 at the bottom. It looks like I came to about 700 feet in distance, and I know all of us may come up with slightly different readings, since we are all manually relying on our precision with hand-drawn lines. I drew my green line a bit thicker than I would recommend actually doing, just so it's easier for us to see in this video, but take care in drawing your lines straight and thin for better accuracy in your results. Now in reviewing our three answer options, we have to choose between A, 650 feet, B, 850 feet, and C, 1000 feet. Though my current answer doesn't match perfectly with any of these provided answers, I would go with selecting the option that's closest to my answer after having double-checked myself just to be sure. Answer A, 650, is the closest to my 700-foot reading with a difference of only 50 feet. Compared to the next closest answer in B, 850, which gives a discrepancy of 150 feet. Answer A is selected as the correct answer by the FAA, and this is an example of how sometimes we have to select the best answer with the 3 options we are given. And that concludes our first practice question. If you would like a bit more practice, we can do one more. And this time, we will go right to the points, a bit more straightforward since we will be applying the same concepts from the first question. But before we begin the next practice question, I wanted to add a few simple things that might be of interest to some people, including a few tips when working these problems during a written test. Feel free to skip ahead right to the question because I finally learned how to make those tabs on these YouTube videos for quicker access to sections of the video. First tip is that there are a few questions lurking in the written test database that assume you know standard atmosphere conditions. Standard atmosphere is sometimes also referred to the International Standard Atmosphere, which we all know that's way too long of a title, so they abbreviated to ISA. You will see this abbreviation on the chart near the top at the pressure altitude section. Standard atmosphere includes multiple conditions that are agreed upon by scientists for measuring purposes. It includes temperature, pressure, acceleration due to gravity, and more. In aviation, we are often focused on temperature and pressure. Memorize 15 degrees Celsius and 59 degrees Fahrenheit for convenience. For takeoff distance questions, the details of standard condition is not clearly given. Or is it? If you're human and happen to forget this standard temperature during sitting for an exam, it happens, don't worry. Just track down this black line under the ISA on the chart, then go straight down from the end of that line and you will end up on the temperature scale right at 15 degrees Celsius and 59 degrees Fahrenheit. Or, as you have already seen, that segment of red arrows from the example happens to mark exactly that spot too. This can be confirmed because it is also described in the blue example box at the top, though it does not label this as standard temperature. Use this beautiful coincidence to your advantage if needed. Next tip will be exposing a common mistake done in the pressure altitude section of this chart. The pattern of traveling parallel along with the black guidelines is done for the majority of the sections. It can become so routine that there is a possibility, the risk, the danger of mistakenly applying this same pattern in the early section of the pressure altitude if we are not careful. Here is what the common error could look like. Take for example, we have a given temperature of 0 degrees Celsius and a pressure altitude of 10,000 feet. So far we have done everything correct until we make the mistake of traveling up the pressure altitude line up to the end and then going across to the reference line. This will place us in a wrong position and carry the inaccuracy with us all the way to the end result. Remember from our first practice question, we did not do that. Instead, let's emphasize that we correctly tracked up from the temperature scale to make contact with the appropriate pressure altitude, and went straight across to the next reference line. Paying close attention to the chart example with these red arrows here can help remind us of this step. Understanding the basic effects that these conditions have on an airplane's takeoff performance will help make sense of these guideline positions and trends on this chart. As we progress through the entire chart, our final position will represent all the listed factors affecting takeoff performance cumulatively. Upward trending guidelines indicate a decrease in performance. Such as with the wind section, we can see how the guidelines for a tailwind go up in a steeper angle, indicating that taking off with a tailwind dramatically affects the takeoff distance. This complements the highly encouraged practice of taking off into the wind, giving ourselves a headwind instead. Because as we can see with a headwind, the guidelines trend downward, indicating that a shorter takeoff distance would be needed, essentially helping to increase performance. With understanding the design of this chart, we can start to see that it makes more visual and logical sense as we have been applying it during every flight, avoiding or minimizing taking off with tailwinds, overweight aircraft, and operating in atmospheric conditions of thinner air. Though we have been focusing on calculating takeoff distance, it's critical to recognize that aircraft performance calculations of any kind indicates only an estimate. Takeoff distances are not to be taken literally to the inches in real-life practice. There are multiple factors present in reality that can affect the actual distance. Some considerations include the fact that these charts are established using statistics from flights conducted by test pilots. The general experience and flying methods of a test pilot rarely matches that of another pilot with a different flying experience or career. Another consideration is for the constantly changing weather conditions, occasions where winds shifting direction or temperatures rising or falling over a short period of time. Even weather reports that are supposed to reflect current conditions do not always exactly match the conditions on the takeoff runway or by the time you actually depart. Runway conditions are not always included in aircraft takeoff performance charts, but can have a varying degree of influence as well. Example factors include paved, grass or dirt surfaces, runways becoming wet from rain or covered in snow or ice. Aircraft condition will also influence actual distance needed for takeoff. As aircraft and their engines age, they generally decrease in efficiency and effectiveness. But it's not always the case, since the quality of maintenance is important with that too. As we can see, what is calculated on paper does not always perfectly translate into reality. So, before I end up recording an audiobook on this topic, let's conclude this discussion for now and move on to the last question. Here we are asked to determine the total distance required for takeoff to clear a 50-foot obstacle. And the given conditions include an outside air temperature that is considered standard, a pressure altitude at sea level, takeoff weight of 2,700 pounds, and calm winds. And with any written test format, we are given 3 possible answers with only one of them being correct. As previously done with the first question, we will plug in all this information into the chart to find the answer. We begin with the first item on the list with the outside air temperature being standard. Remember that standard temperature is 15 degrees Celsius and 59 degrees Fahrenheit. If you need help remembering this, you may like to use the beginning portion of these arrows as they happen to align with standard temperature. These red arrows are from an example question that's included in this chart. So we will start down here near the lower left area and position ourselves on the temperature scale over 15 degrees Celsius or 59 degrees Fahrenheit. And from that point, we will track straight up towards the heavier black guidelines for the pressure altitude. In the next given condition from the question says we are dealing with sea level conditions. So that means we will stop right at the point of contact with the first line that's labeled SL for sea level. And from there, we will track straight across to the right up to the vertical reference line that borders the next section on the chart. Now we have made our point on the reference line. When we move forward from here, we will have to follow along the downward trend of these black guidelines, like going parallel with their direction. We will continue this downward progress until we reach the given weight of 2,700 pounds. We will refer to the weight scale below to find where we will come to our next stop. Once we have reached the point of 2,700 pounds, we will then track straight across from there to the next reference line. Now entering the wind section, our given wind conditions state that winds are calm, so we will track straight across all the way to the next reference line since we don't have a headwind or tailwind that applies to this situation. If we did have winds, we would again track parallel along these lines as appropriate. And finally, arriving at the last section, we were asked in the question about the distance required for takeoff to clear a 50-foot obstacle. So that means for this section, we need to travel up the black guidelines all the way up to the end of this chart, since that's the point where the 50-foot obstacle is represented. Our final position at the very edge of the chart will be our takeoff distance. Our readings may differ slightly because we are all manually hand-drawing our tracks to be as precise as possible. Here's an extra magnified view of my final result. Every one of these thin lines represent 100 feet, and there is a 1,500 foot mark right in between the 1,000 and 2,000 feet. So counting down from this 1,500 foot mark, there's the 1,400, and my green line is sitting right at the start of 1,300 feet. Reviewing back to the 3 possible answer options, we will choose the best available answer. With a difference of 100 feet, answer B, 1,400, is my best answer.